So for those of you that missed yesterday, all I'm doing is covering the last thing that's in Chapter 6 today. The first one, the stuff that was covered yesterday, was that the similar polygons theorem. So you need to watch the video and understand how to relate pieces of similar polygons. The only thing we're going to cover in class today is the perimeter of similar polygons. And that is Theorem 6.1. You have your postulates and theorems book because it was assigned last week to have ready for yesterday. So it says if two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So it says ratio of perimeters is equal to the ratio of corresponding side lengths. And this is only good for similar polygons. So again, from yesterday, similar polygons, what does that mean? Somebody that was here yesterday? The same what?
The same shape.
The same shape. So similar polygons have the same shape. Like Kylie with 1E said, they have all the corresponding angles are congruent. What do we know about the corresponding sides in similar polygons?
Proportional.
They're proportional. So they used, in your book, they made a quadrilateral. On the notes, I'm not going to make a quadrilateral. I'm going to make two triangles. And I'm going to tell you that triangle ABC is similar to triangle DEF. The similar symbol is just the tilde, which is the top part of the congruent symbol. That's the same shape portion of the congruent symbol. So what this says is the ratio of the perimeters. So we take the perimeter of the left-hand triangle over the perimeter of the right-hand triangle. How do we find the perimeter of a triangle? Add up all the sides. So the perimeter of the left-hand triangle is the length of AB plus the length of BC plus the length of AC. The perimeter of the right-hand triangle is the length of DE plus the length of EF plus the length of DF. That is the left-hand part of this equation. And that is equal to the ratio of all the corresponding side lengths. And this is the exact same things that we did yesterday. How many ratios am I going to have in a triangle? Three of them. And they have to be the same way I set it up. Here, this was the left side over the right side. Left triangle over the right triangle. So I'm going to end up with three separate ratios here. The first ratio I'm going to do is the left-hand side to the left-hand side. So AB over DE. This ratio is equal to that ratio, which is equal to BC over EF. Which is going to be equal to AC over DF. So basically, if I double each of the sides to go from this figure to this figure, what's going to happen to the perimeter? It's going to, if I double everything going from here to here, what's my perimeter going to do? It's going to double. Okay? So let's say this is 1, 2, 3. And this was 2, 4, 6. How much does this add up to?
6.
How much does this add up to? 12. I doubled everything, so I'm going to double everything. Any questions?
No.
Please open your books to page 360. What I just calculated here, any one of these ratios, for those that were not here yesterday, if I take the left figure over the right figure, I get what's called, if I take the one that they tell me, so if you look at the bottom examples where it says, find the scale factor of F, G, H, J, K to A, B, C, D, E, the first one goes on top. The first one that they list is going to go on top of the fraction when you go to calculate the scale factor. So please do 4, 5, and 6. I'm going to pause the video while you work on those, and I'll go over them. So for the first one, they want to know the scale factor. So I need to find a piece that has a corresponding side length that I can match up on the left-hand polygon to the right-hand polygon. And there's only one side that has pieces that you can match up with the numbers on them, and that is the top segment. Do you guys see that?
Yes.
So it wants the scale factor of F, G, H, J, K to A, B, C, D, E. This one on the left goes on top of our fraction. The one on the right goes on the bottom of our fraction. Then we simplify. Any questions on number 4? Yes, Nikki?
Yeah, how?
Top of the left,
Yeah, I know
right
that.
over top of the left. That's the definition of scale factor.
Okay.
X equals, we're going to set up a proportion. I'm going to write left over left. X over 18 is equal to top over top. Okay, and that was part of yesterday's stuff, because corresponding parts are proportional, which means the two ratios are equal. We're going to simplify before we multiply. What number goes into both of those?
5.
5. So what was my fraction going to be?
2/3.
Okay. So I can't simplify here. I can simplify across the tops and across the bottoms. What number goes into both 3 and 18?
3.
What?
3.
3. 3 goes into 3 how many times? 3 goes into 18 how many times?
6.
Now, what I'm left with is x over 6 equals 2. What am I going to do to both sides to solve for x?
Divide by 2.
No, I'm not.
Times by 6.
Oh.
Times by 6.
Multiply by 6
Oh,
and
why
you get
was
x
that?
is equal to 12.
Why was it 18?
Because left over left equals top over top.
Okay.
And the one I picked to start out with is the one with the x. That way my variable I'm solving for is on the top of a fraction.
Yeah.
What is the perimeter of A, B, C, D, E? Well, you can go and figure out what these other 3 segments are. That's a waste of time. All I have to do is take the perimeter of the big one and multiply it by 2/3. Because this one is 3/2 as big as the other one. Just have to take it and multiply it by 2/3.
Oh, okay.
That's what I
This
did.
one.
Took that 18 and multiplied it by 2/3. So what I want to do is figure out the perimeter of the big one. 24 plus 12 is 36, plus 15 is 51, plus that would be 69. What is 2/3 of 69? Anyone? What's 69 divided by 3, people?
23.
23. What's 23 times 2?
46.
46.
Yeah.
This was 69 times 2 over 3. Well, 3 goes into here 23 times. 3 goes into there once. 23 times 2 is the 46. Questions on those?
I don't get how you did 6.
How did I get which part of 6?
The perimeters.
How do I got the perimeters? What's the definition of perimeter? What's the definition of perimeter?
I don't know how you got 46 for that.
I took 69 times 2/3.
But why did you get 69?
You add up all the.
I did the definition of perimeter. 15 plus 9 is 24. 24 plus 12 is 36. 5169. Then I multiply that by 2/3.
I didn't look at the equation. I wrote them.
Okay, that's why I asked you, what is the definition of perimeter? It's adding up all the side lengths. So I added up all of the side lengths.
I just had a shot note, sorry.
Now, the other thing you could have done is you could have taken each of these numbers, multiplied it by 2/3, which means you're going to be doing that fraction a whole bunch of times. Now let's see if it works. What's 9 divided by 3? 9 divided by 3.
3,
3 times 2 is?
6,
12 divided by 3.
4,
Times 2?
8,
15 divided by 3.
6,
What?
5. Sorry.
Times 2? And this should make sense. If that one is a 15 that goes to a 10, and that one's a 15, what's that one got to go to? And we already calculated that one. So now let's add these things up. 10 plus 6 is 16, 24, 34, 46. Two different ways to do it. Doing it the first way is using the theorem. Doing it the second way, if I give you a 12-sided polygon, is going to be a waste of time. Because you're going to end up calculating 11 of the sides if I give you a 12-sided polygon. You don't want to do that.
Yeah.
Okay, you want to use the proportions of the ratios with the scale factors. Any other questions on that theorem 6.1?
Not really.
Your homework is on the board.
Yeah.